Today we do the reverse engineering. How many of you heard me say reverse engineering about a month ago? Okay, reverse engineering means we don't do lesson first, we do question first, okay? Because you guys are familiar with the concept of magnets quite a bit, and we just need to know how to magnetize and demagnetize for today's lesson. So which means you have to have some concepts, okay, in your mind going as we do the questions, okay? And the end of the questions, we will summarize what we need to know, okay, what actually we need to know from this topic. Okay, this is another way of learning, which usually I find that it can be more useful because from the questions, you know exactly what your teacher is going to ask you, and then you learn. Rather than you learn, you can, if I ask you to say, here's a, okay, so I have a textbook here, right? Here's a textbook, PSLE book, go and revise magnets. You don't know what to revise. You have to revise the whole chapter, and it has 15 pages. You're like, huh, you mean I must read all the 15 pages by tonight, by 1 hour's time? Yes. I will give you a test. Yes. What do I study? What do I concentrate on? Difficult to know. If you have a set of questions and you're revising, you will know exactly what is to be taken from the notes. Okay, so that's what we can do, reverse engineering. So let's start. Okay, you might have been busy with schoolwork, and I understand that. So if you have yourselves 1 minute per question to just read through it, the slower ones will still be reading, while the faster ones will have read and got me the answer. Okay, so it's fine. We just try to get to the answer with my help and your help, especially those who are faster. Okay, you can always type the answers to me. Okay, come. Devi, first lady in the house, Miss Devi comes to the house. Remember, in all our science question, like I said many times, we always welcome friends. Some Devi, some David, some John, sometimes Mr. John, sometimes a teacher. Okay, so we get to know a lot of students actually, but never our real names, right? Unless our names are a bit common that we might have. Okay, Ali has appeared a lot of times. My name has appeared a lot of times. Devi was trying to turn rod Z into a magnet. Okay, rod Z obviously is not a magnet at first. So what is it then? It must be some sort of metal. Okay, not a magnet, but she wants to make it a magnet by stroking method. Okay, so I'm going to method that she's going to use. Right? And she used the bar magnet, and then now you have poles on the magnet, north and south. The strokes are represented by the tools. Watch the video carefully. You don't 2D diagram doesn't really show magnet on another. Also show you. If I had the opportunity, example, if you're looking at me on the screen, this is what I'm trying to magnetize. So stroking will be in one direction, and then you don't go back on the same way. You just go one direction, you take up, and then go another line, go up, another stroke. So this is called stroking. Okay, you go round. You do not go left, right, left, right. This is wrong. This is stroking. So it's been shown to go in the direction of left, right. Okay. She was unable to use this method to turn into a magnet. Which two of the following statement could be possible explanation? There you go. Why is it the wrong method? Because she's going left, right, left, right. Any idea? So we read through A to D. Rod Z is not a magnetic material. Could be a reason. Could be because this rod is not a magnet yet. It has to be a metal, and it has to be only the 4 magnetic materials. Then only can become a magnet. What are the 4 magnetic materials? So you cannot choose any magnet. I mean any metal. You have to choose the 4 metals. So let's say you want to make a magnet. You have to go in search of these 4 magnetic materials to make a magnet. You cannot just make magnet with any metal like aluminium or copper. No. So you need cobalt. You need iron or nickel or steel. Okay, these 4 are okay. So maybe Devi didn't get her hands on these for materials. So maybe this is the possible. That's why she cannot make it a magnet. The bar magnet must be the same size as the rod. Hey, this is not necessary at all. This is nonsense. Okay, those of you who have been with me for a long time, you know I use the word nonsense, and I've taught you nonsense is not a bad word. It's just the opposite of sense. It's just nonsensical. Okay, it's not sensible at all to say everything must be the same size, then you can make magnets. It's nonsense. Devi should stroke rod Z with the south pole instead. No, not necessary. You can stroke with the north pole also. Only the polarization will change. Okay, you can make, if you stroke with the north pole, you will get a north pole and a south pole in one direction. That one will come to it in the next question. So you know you don't need to stroke it with one particular pole. You can use either pole. Last, the biomagnet stroke in rod Z is more than one direction. Yeah. Is 1, 2, 1, 2, 1, 2. It should be one direction this way. So left to right, left to right, left to right. Okay. You know, you write your composition, you write left to right, right? Then Chinese compo, you write right to left. Or is it left to right? Ha, I caught you there. So left to right, right? The olden days we used to write left to right. All right. So imagine if you write a composition left to right, right to left, left to right. Every line you change. That's it. Your English teacher is going to go mad, right? Imagine first line, you write, one sunny morning, Devi had a nice breakfast. Then you write below from the left and you try to make it a zigzag line. Oh, your compo will be a mess. You don't look creative to you, but it'll be a mess and you will never be a compo. So similarly here, it has to be one direction. So let's go and say A is the answer. Okay, I'm going a bit slow, so that you all can catch up. Those of you who are just coming in from class, from school, some of you are in primary 4, I still see people entering. So we should go a bit slow until they all come in, then go a bit faster. And also, I hope all of you can also catch up on the magnetization. Later, I will be asking you to take part in what I call the reverse engineering, where we will write down all the things that we learned in the questions. How many questions do we have today? I gather it's about 10. Okay, so we still have time. Let's do it slowly, because this is the more important part that we tested rather than the first 2 lessons of magnetism, where we just find out, oh, how many pins can this magnet attract? Oh, 4 versus 3. Oh, this one is a stronger magnet. So easy. This is too easy. Then those kind of things don't need to revise. Even when you see the question in the exam, even in primary 5 or even sec 1 or in primary 3, you'll still look at the magnet. You'll be like, oh, this one can attract 3. This one can attract 6. Obviously, 6 is stronger. Oh, okay. So no need to study very hard. But this type of questions you need, because you need to know the concept very well. Okay, let's go. Another method. Okay, so the first method in question 1 was, so we can also identify the methods being used. It's called the stroking method. Now in question 2, they are making a magnet, but it's not stroking. It's called the, right? So there are 2 methods. You can make a magnet with some electricity as well. And to bring in electricity, you need battery. You need battery, you need wire. If the wire is there, do you just connect it or do you like coil around it? This thing you need to know. So you need to coil around it because you want the current to be going round and round and round the object. Okay, so the object will be inside, and then the wire will go round and round and round, and then we'll connect back to the battery like this. Okay, this is a symbolic way of writing. Now this one on the left is a drawing. So Gopal wanted to find out if the number of batteries affects the strength of the electromagnet. Does it? He prepared 4 setups. Which 2 setups should Gopal use to conduct a fair test? He wanted to test whether the number of batteries are, so you must change this, right? You must change whether you must put 1, test 2, then test 3, or test 2 and 3, or 2 and 4. So he need to change the number of batteries in his both experiment, and the rest you should keep the same. Rest unchanged, right? Okay, so the rest unchanged. That means number of coils here, number of coils that you go around the object must be kept the same. The type of metal that you use, which is a nail, must be the same. The battery type must be the same. Cannot be one small battery and then one big battery. Okay, that also must be the same. What must you change? Only the NUMBER, the number. Change the number of batteries. So which diagram shows you everything is the same, but the number of batteries is different. So 20, 20, 10, 10. Okay, you can choose 10, 10 or 20, 20. So it's either the A and B pair or the C and D pair. So it could be only A and B or C and D. So these two or these two. So which one do you choose? Okay, time's up. Both look like it's possible, right? Am I right? Wanted to find out, he prepared 4 setup as shown below. Everything should be the same. So how many of you chose D? Very good. How many of you chose A and B? Don't have the option. Yeah, no wonder. So actually A and B also can. Okay, so this is a trick question. Huh? A and B also can. A and B also can. Why? Because there are 10 turns, 10 turns, same nail, same connection, but battery change 1 to 3. Can. If you put more batteries, does it become a stronger magnet? Can test. But they did not give you in the answers. So that's why you choose, oh, so no A and B, so let's choose C and D. That's the way. So doesn't mean it's not there, it's not the answer. C and A. So let me just write it down. A and B are also a possible pair for a fair test. Okay, just to make the point clear here. Number 3, back to stroking. Study the diagram, you stroke. Okay, during an experiment, Carol used. Now in your mind, you have to be thinking at this point. Okay, let me write down. If this is N and this is S, then what will be the poles here? So I know some of you already know, some of you are still not sure. So by the end of today's lesson, must know. So look out for it. Okay. During the experiment, Carol used bar magnet to stroke object X repeatedly for 30 times. Wow. Okay. Another way the magnet can become, I mean, any object can become a magnet. It's not just stroke one time. Must stroke repeatedly until it becomes a magnet. So for example, you stroke 10 times, it's not a magnet yet. Then maybe you should stroke 20 times. 20 times not a magnet, stroke 30 times. Because your stroking is helping to align the molecules, atoms inside the magnet to be in one direction. So it takes time. So the more you do it, the more you straighten the particles inside the object X, where the poles will become north and south. Okay, so what I mean by that is usually a non-magnet has polarities that are confusing, all jumbled up. Okay, so what happens is when you do that, when you stroke, what happens? You have to make them all in one line, therefore causing the magnetism to form. So so inside a magnet, you will see magnetic field lines like that. Therefore, one side will be the North Pole, one side will be the South Pole. All right. So based on the above experiment, which of the following statement is correct? Object X is a magnetic material. Because she managed to stroke after that, object X was able to attract. Yes. Did it become a magnet? Yes. Did it become a magnet? Earlier, remember in question 1, I think, she wasn't able to make a magnet, Devi. And we need to find out why. But here, who is this person? Carol. Yes, it became a magnet. So she succeeded. Because why? Because it attracts some paper clips. Okay. Based on the above, which are following statement. Object X, magnetic material, definitely good. Object X is non-magnetic. No, these are two opposite things, right? It's either a magnet or not a magnetic material. It is. Meaning, it's a nickel, iron, cobalt, or steel. The magnet lost all its magnetism after it was used to stroke object X. No. This magnet we're talking about is this one. This magnet. lost all his magnetism. Do you think it will pass his magnetism? You'll say, okay, now I pass my magnetism to you. Now I lost my magnetism. No. Okay. It will still have its magnetism. It's a strong magnet. You need to use a strong magnet and it will not lose its magnet. Especially, usually we call that a permanent magnet. You need to use a permanent magnet to do this type of magnetization. Even whether be it stroking or any other methods, you need a permanent magnet to do. Okay. Loss is all magnetism. Cannot be. So I'm going to write cannot be. Okay. So this is also wrong. Obviously, we already know the answer is A, right? Or no? Some of you still say D or A. Victoria, is it D? The more times object X was stroked, the less number of paper clips you attract. No. The more times you stroke, the stronger the magnet will become. The more, so this one should have been, more clips will be attracted. So this is a wrong statement. Okay. Just remember, stroking. Remember, I say if you stroke 20 times, it's still not a magnet yet because you've not created the straight lines inside the magnet. Can you see all the red lines? Okay. The more you do, the stronger and stronger and stronger it becomes. So the more and more paper clips it will attract. So it should be more, not less. So more and more. So that's why D is wrong as well. So answer should be A. And A, if you have, those of you who have A and D as the answer and you're confused in the exam, what do? Which answer is stronger? I mean, you know for sure is correct. Object X, the magnetic material, is for sure, because otherwise, how did it? Because you see this? See, I'm drawing a star here. This statement is true. If it became magnetized, it's only possible if it was the one of the four materials, one of the four metals, which are the nickel, iron, cobalt, and steel. And therefore, option A says that. We are 100% sure option A is correct. Then option D is like, I'm not too sure. So I should just put, so even if you don't know, just put a question mark. Okay. Then you look at the question. Which one got tick? Which one got question mark? Which one got cross? That's it. Cross and cross surely out. Question mark means don't know. A means surely correct. So choose surely correct, right? Then you won't go wrong. Setups below show the making of a magnet using the electrical method. Back to electrical. So we keep jumping from the two methods. So you know that, hey, you don't need to study your notebook. You don't need to study your textbook. You know by now that there are two methods to making a magnet. One is stroking, one is electrical. How to do electrical? Just now Mr. Ali showed you. He put magnet, he wire them, he make sure he coil the metal, and that's it. Done. We've seen it in 2 questions now. So by this time you already learned. No need to look at the textbook at all. The setups below show the making of a magnet using the electrical method. Which of the following setup will attract the most? Okay, I'm going to highlight. Number of paper clip. That means must be the strongest magnet. And what are the conditions in an electrical method? You either use more batteries. Since you're going to connect a battery anyway, you can connect 1 battery, 2 battery, 3 battery. 3 battery will connect with more current. More current, stronger magnet. Okay, so more magnets will do the trick. Next one is more coil. Okay, the coiling is the most important part of making the magnet. Okay, coiling effect. So if you only make 2 coils, say for example 1, 2 versus 1, 2, 3, 4, 5, 6, 7, and then you have the same object inside. Can you see? Same size, same object. Which one will become a stronger magnet? The one with the more coils will become the stronger magnet. And therefore, your objective here is to make the stronger magnet. You need more coils. So let's look at the answers that is possible. I think this one you know straight away, right? What's the answer? More batteries and more coils. Which one has the most number of batteries and most number of coils? Answer is da 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 do do d d d. Angry birds. Okay, let's go. Shane turned 4 identical iron nails into electromagnets. Okay, using the electrical method. So I'll let you read first, then we talk about it. Okay, Shane turned 4 identical ions. Read ready? E, F, G, H. Okay, read ready? Electrical method. Okay. Which of the following correctly identifies strongest and weakest? Same as question 4. Now you're expert already, right? Now you can answer the question. No need to sit down and study anymore. Teacher, I have tests. Mommy, daddy, I have science test tomorrow. Don't have to study textbook. Take the question. Your parents bought for you so many assessment books, right? Straight away, go to your shelf, pick out the science assessment book, go to Magnet, sit down and do. After 1 hour, done. You studied already. Instead, you take the textbook with no question, just read. No matter how many times I test you, you're going to not pass with full marks. But by questions, you are. That's exactly my purpose for today exercise, which shows you how questions, these questions are all taken from all kinds of papers from different schools, different exams, PSLE and so on. And it shows you very clearly these are the only type of questions that will face you, whoever you are in front of me. Your name is Corinne, Usha, Victoria, Celine, Jubi, Lasia, whatever your name is, this Branson, Adi, Aiden, this is the paper that will sit in front of you. Nothing more in this magnet, right? So why are you afraid? Because you've seen this question with me, you will see the same questions in the assessment books, and then you become familiar with like, yeah, I know what question is going to come in tomorrow's magnets test paper, because it's exactly. So this one thing is exactly the same as question 4. I'm going to just reveal the answer because all of you have typed the answer to me. Answer is D. Very good. Why? Because you choose more batteries and more coils for stronger magnet, which is H. And the least battery, which is 1 battery, with the least coils, you go and count the coils 1, 2, 3, 4, 5 versus 1, 2, 3, 4, 5, 6, 7, 8, 9. And you get, so therefore, easy. All right. Richard made 3 magnets using the stroking method. Okay, this is a bit longer. By this time, I'm thinking these guys are ready for a tougher question. So if you are ready and you have answered, if you have your answer, type straight away, because I know these people who are typing the answer straight away and getting it right according to my answer on my paper are the ones who did the homework. So type now. I want to see how many of you can type the answer straight away. Those who cannot find the answer means you didn't do your work, you're doing it slowly, but okay, I excuse you. You take your time and do, and still give me the answer. Option A, B, C, or D. Okay, thanks for those who are replying quick, but it's okay. Just hang on till all our friends finish. Okay, this is what I call the analytical question. Okay, you need a lot of things. First, they show you, first, they give you the, okay, as you all are doing, maybe I'm disturbing you. Maybe, okay, I'll let you do first. I'll give you another countdown, 30 seconds. I'll be quiet. Okay, my alarm is off. Okay, now we just need to match the 2 data. This is called the text story. Sometimes you don't even need the text story. Maybe I don't even want to read the text story. You should read, okay? If expert like me have 15 years or 25 years of science experience, I don't need to read. But you guys just starting science must read, okay? So this is the diagram. Okay, this is the data 1. This is the data 2. Usually you only have data 1, but now you have data 1, data 2. So you have to match data 1 with data 2 and also see the diagram and also see the text. So you can see how many things I've written down there on the screen now. 4 things, okay? That's why it's going to be difficult. So you need to pick up, maybe you should read first, okay? Richard made 3 magnets. Oh, 3, that's why you have 1, 2, 3. They're called X, Y, Z. Using stroking method, okay, the method stroking. He made them already. He made the 3 magnets already. Made already, yeah? Realize he made. So I should highlight the word made as well. Made. So past tense, he made. He used the same bar magnet to stroke all 3 for different number of times. Okay, so that means very simple. Straight away in your mind, you're like, oh, that means one magnet will be weaker, the other magnet will be stronger because the other one he stroked many times. Then he placed one, then also must make sure he stroked correctly. Okay, if you stroke correctly, he'll get a proper magnet. And slowly push the paperclip towards until the paperclip was attracted. You want to see which is the strongest magnet. Distance at which the paperclip was attracted to the magnet. 5 centimeters. If you can attract something from very far, 5 centimeters is the strongest magnet. If you have to go very, very close, then you can attract something that is the weakest magnet. Am I right? Okay, that is data 1. So I already write down my strongest and weakest magnet. Now, I just go and say, oh, so Richard must have made the strongest magnet X with the most number of strokes. So X must be the highest number compared to any others. Any here also, D also can. Am I right? Please see my yellow shading for X. X must be more than Y and Z because it's the strongest. Therefore, A is out, B is out because it's not the strongest. It's not the most number of strokes he used. One he stroked 10 times, one he stroked 20 times, and another one he stroked 30 times. So X must be stroked 30 times for it to be very strong, for it to be able to attract something 5 cm away, far away. Got it? All of you got it? You good? Can I continue? Can, right? So now you zoom in on C and D already. Now, the next one is weakest, or you can go for the second weakest. I like to go for the weakest, must be 10 strokes only. So there you go, red color, I highlight the 3 cm. So let's check here, and let's check here. That is the letter Y. Y has to be the shortest. So therefore, this is correct, and this is correct? Wrong, right? Y is not the shortest, it's the medium. It has 20 strokes, so it's wrong. Understand? So answer is C here. Okay, again, easy question, but looks difficult. I hate people who say it's difficult just by the way they see the question. Lots of you are guilty of this, okay? You see a question, lots of things, long text, long pictures, big pictures, and 2 data, that's it. This question, stuff I don't want to do. I think this question is very easy. Yes or no? This question is super easy. All you have to do is find out which was the strongest magnet he had, Richard. Then you just go straight, zoom in on the yellow text that I wrote here. You see on the left where I put a star now, can you see writing star? If you get this, this means you have got your answer already. So easy. Thanks, Pranshu, Victoria, Adi, Jarek, and all of you who participated. Thank you so much for giving me answers. Yes, positive, easy, easy, easy. Yeah. So, like I said, now you say easy, but don't give up when you see the question, okay? Every question, in fact, when you see in primary 3 exam, if primary 3 don't have exam, primary 4 have exam, don't say difficult because it's not, they're not giving you primary 6 question or set 1 question, they're giving you set primary 3 question, which was inside your assessment book all along, which you did in your homework all along. But they just want to make it, obviously it's an exam one. If it's an exam, how can I make it like class homework? Homework and exam, is there a difference? Yes. Test and exam, is there a difference? Yes. Why? It's supposed to test if you know those things that we've been doing along all these months. Okay? So you revise the test, you revise the homework, you actually prepare for the exam. Or I know many of you do this other thing which your parents help you to get to do. What is that? Do all the past year paper. You are in, I don't know, Taunan Primary School, then you get to do River Valley Primary School, Raffles Girls Primary School, ACS Primary School, every school paper. Am I right? Yeah. I know. Yeah. Everybody do it, right? Why? Why do you do that? Why don't your mommy just go to Popular and buy more textbooks? There are tons of textbooks or more revision notes or more notes. They buy for you, they get for you the papers online. Why? Because they know, and we know, and everybody knows that the papers contain these valuable questions that help to train you. Okay, so look at the questions and that's enough. I think that's the best advice I can give you forever. Now, last one, not last one, next one. Peter used the setup to attract some pins. Okay, this is an electrical method. Obviously, you can see everywhere, every question is about making a magnet. So did you have a magnet in the first place? No, not yet. But you had a metal. What metal did you have? What metal did you have in your possession? You had something called a nickel, iron, cobalt, or steel. One of these four. And then you made it into a magnet. Okay, so make sure you realize what's happening. You didn't get a magnet straight away. So when you get the magnet, some metal, you make it a magnet. You can make it strong, you can make it weak. Also realize this. You can make it strong, you can make it weak. How to make it strong? Then you need to know what are the steps. You need to put more batteries or more coils, right? For stroking, you need to stroke more. That's it. Okay, in the proper one direction and not in any direction. These four things are what we have learned till now. And we keep using those concepts. Now he added more turns of the wires. All right, so that means we all know why he's doing this, right? Peter, why are you doing this? Peter, why are you doing more turns? Then he count the number of pins. So if you do more turns, then he's going to attract more pins. His results in the table are shown. So the number of turns from 10, he go to 50, then he go to 100. Wow, that's 10 times more. From 10, so he takes his time and effort. This guy is a really patient guy. He goes, wow, let's do 50 turns, 100 turns. Because not only he's patient, but actually he wants to make a very strong magnet. I know all of you guys, right? If you have a magnet, something, like, yeah, come, let's make it more powerful. Like when you play a game, like even you play eraser games. I know you play eraser games, right? About the girls, the boys. Eraser is to what? Win the other person's eraser, right? You put the eraser and try to win them by pushing it over it. So you want a stronger eraser or not? In every game, you want to win. So you try and go home and think and find a way where you can get an eraser that is the best. Nobody can win you. Then you are the ultimate what? Record holder. Okay, so in this way, you also want to make the strongest magnet. So this can be a competition between all of you. If a teacher gives you a metal and say, all of you go home and come back. I want to see you making the magnet. And then we come back to school the next day and we see which one of you can attract the most number of paper clips on my table. So all of you rush to her table, to your teacher's table, and then put your magnet for test. Obviously, the person who attracts the most number of paper clips will win. And for that, at home, what do? You break kiasu, right? Actually, 10 coils are enough. Or is it not enough? Cannot. You look at the data there. 10 coils cannot even attract one pin. So, but you don't know yet because you don't know what pin your teacher is going to give. So all you did is you did with 10 coils and then you went to school. Actually, you didn't manage to pick up even one pin. Then some of you could 50, top 50. Yeah, I'll be the winner. I'll surely get the one because the rest will just do 10 or 20 or 30 or 40 or 50. I do 50, I'll be the winner. But you did not know your other classmate seated next to you or seated right there, right at the back. He a bit careful. He go and do 100. Some of you may think, okay, so maybe John will do 50. I shall do 60 and I'll win him. But you never knew Casey did 100 coils. Okay, so depends on your patience and ability and how long the wire is also. Hello, if you don't have enough wire, how can you make 100 coils? Am I right now? Yeah, okay. Depends on how long. Okay, which of the following best explains why no pin was attracted with 10 turns around the rod? That's all. So they didn't talk about Casey, they didn't talk about Matt, they talk about John. The John who was the failure. He was a failure because 10 coils did not work for him. So they're going to ask, hey, how come John's one did not work for him? The battery was not working. No, because he used the same battery in all three. So in this case, there's only Peter. There's no Matt, there's no John and all that. Okay, so what is it? There's only Peter, right? So Peter used the same battery on all three. So it's not about the battery. It's not. It's the same battery in three. So cannot be battery not working just for the 10. So this is definitely wrong. What else? The rod was made of non-magnetic material. Wrong, because he used the same rod. He only changed the coil turning. So how can it have 50 can attract and then 100? That means he must have used a magnetic material. He must have. based on the fact that he was able to attract 2 and 5 pins. So the 0 pins is not because of the material. Must be because of the not enough coils there. The pins were made of a non-magnetic material, not of the pins. Hello. Again, 2 and 5 pins were attracted. So they are magnetic. Hello. Again, nonsense. I'll call this what I categorize in my dictionary as nonsense. So B and C is actually nonsense because in the experiment it worked. Pins were attracted. They were all magnetic materials. So there's no way they're non-magnetic. They're talking about this non is the nonsense part. Nonsense. Okay. The electromagnet was too weak to attract the pins. Yeah, it was too weak. He did not make it strong enough. Because to make it strong enough, you need more coils. Okay. I know so all of you are already on D already. You jump the board. Okay, but like 5 of you are very smart. And another 5 of you are medium smart. And another 5 of you are lazy. So you didn't even do the question. That's why I'm going slowly for everyone to catch up. Okay, sorry for being too slow, but don't worry. As long as you're learning, and those of you who are fast, you're actually learning again and again with me by me having me to repeat the things that you already know. You're like, okay, what I thought was correct. Mr. Ali also said the same thing. Good. And then you also can teach others. If you start teaching others, that's when you realize that you are super good at this topic. How many of you actually teach science to your friends? I know you do. How many of you teach math to your friends? I know you do. Which means you are as good as me. You are as good as the teachers because you understand and you're able to teach. Okay, now this is another example of a question that can be what? Somebody can give up because the diagram looks a bit complicated, but it's not. It's all based on the number of coils. This one you can count. Can count or not? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think it's about more than 30. I'm not going to count anymore. Around 30. This one, the coil is 2, 4, 6, 8. This one, the coil is 2, 4, 6, 8 also. This one, the coil is 2, 4, 6, 8 also. Okay. Okay. This one, 3 batteries. Okay. So you can see or not? What are the things? 1 battery, 3 batteries, 2 batteries, 1 battery. Which 2 setups should Joy use to ensure a fair test? For what? Fair test for what? Now, depends on what must not change versus what must change. What must change is the most important thing. That means she's going to test to find out if the number of coils. Okay, this is what must change straight away. So must change. Change the number of coils. The rest keep the same. Okay. So which one changed? D, definitely she changed the number of coils. So D, not D. Setup S. Setup S must definitely be in the answer. So setup S, I'm going to choose, must be in the answer. Because it's S together with another one where they have 8 coils only. One has 30 coils, one has 8 coils. So the rest of the 3 got 8 coils. So which one do I choose? I must choose with the, let's choose a red color. And this is the important guy. And this guy says I have 30 coils. So I'm going to compare with another one with 8 coils. So should I choose P, Q, or R? Now I choose the one, everything else must be kept the same. So let's go to the yellow color. This guy says 30 coils with 1 battery. Therefore, I must choose the other one with also 1 battery. Understand? This is how I choose. Okay. So therefore, I cannot choose the one with 3 batteries, 2 batteries. I have to choose the one with 1 battery. And the 1 battery is setup P. That's why answer is D. Okay. Step by step, it will never get wrong. Iron bar was magnetized. Stroking. Identify the magnetic poles of the iron bar formed at parts X and Y. Now we have come finally to name the parts. But it's a bit confusing because you have 2 magnets coming from the center to the end. So what happens is usually you have this, and you have this, and you have N, and you have S. So if you go this way, if N touch first, this will become N. and this will become S. Okay, the one that touch the magnet here will become the N. So let's say there's another magnet here, and then you change it, and this is S, and then N, and you stroke it this way. What will it become? You touch S first, so it will become like this, right? So here, I give you a chance to try now. There are two magnets, they are coming down in the center, they start here. And then they go here. So maybe I should draw here, right? So here will be S, here will be N, here will be N, here will be S, okay? Because this magnet touch here first and then go here, right? So touch, N will be here. This magnet touch here first, so here will be S and then go here. So this way. So the one, like I said, you see these two where it touch will be the same. These two where it touch will be the same, where it touch first. So that is why it will be X will be N and Y will be S. Answer A. Okay. As you do more, you may have to come to terms with this convention of naming the poles. Okay. So this is just a start, because in whole of today's questions, this is a question we first encounter, naming the poles. Okay, don't worry, we will do more if we can. Jamal prepared the following 4 setups. This one is easy again, so I'm not going to go through. Right? I will expect all of you to just tell me the answer and we move ahead, because we want to end the lesson already. And then we want to know what we learned today. Okay? So I'm going to show you some of the questions that I want to let you try. Okay? Not going to go through, because what I already went through today is going to come as a notes. So I'm going to go through the notes now. It will take me about 5 minutes, okay? Or even less than that before we say goodbye. So these questions I just show you to say that you should put into practice what we covered today. And then these are the type of difficult questions that you may need to go through first before looking out for the answers, which I'll post by tomorrow. So this question 11, question 12, question 13, okay, all is for you. Okay, and last week I gave you an exercise to make a compass, which I just put it here so that I am reminded whether you guys did or not. I know, like I said, I encounter so many students, I know you all didn't do this, okay, but it's always there for you to do if you want to. Okay, so let's do some summary. Okay, 5 minutes and we are done. Let's do some summary of what we did today. Number 1, okay, is magnetization. Number 2, we didn't do demagnetization, no, right? We only did magnetization. How to do magnetization? We do stroking method. Number 2, we did electrical method. Okay, and both methods, what is the fundamental important thing you need to have? What are the things you need to have in order to employ this method? First. In both methods, what's the common thing you need to have? You need to have the metal that you want to make it a magnet into. And that metal must be called a magnetic material. Am I right? It must be. So in both cases, you need to have a metal, and it must be magnetic material. And therefore, these 4 magnetic materials you know by heart are the 4 CIN. What? Come, say it with me. Cobalt, iron, nickel, and the last one, steel. Okay, I've taught you many ways of remembering them. By now, you should know them. You need to have these 4. Okay, so these are the common. Now, what do you need in the second item? The second item is not the same item. We need a permanent magnet that has a north and south pole. And then the method actually is to stroke it. This one, you need to wire it up. So you need a wire, you need battery or batteries. Okay, depends on how powerful you want to make it. So if you want to make it powerful, you take more batteries. No batteries, take one battery, but take a long wire, coil more. Okay, so some of you have questions like, how do I coil more if my wire is short? Just take a longer wire then. You only can coil as much as how long the wire is, right? So either the wire must be long or the battery must be more batteries, or you have both. If you have both, you are the winner, right? So your magnet will become the strongest. And then, so it will depend on the number of coils and the number of batteries. Stroking method, it will depend on the number of strokes. So this is all you have been tested so far. Now, if this is one side, how about demagnetization? Remember we saw in the video demagnetization? Now, it is good to know, but we don't test you extensively on demagnetization because we will first need you to be very good in magnetization. Then we talk about demagnetization. Okay, so demagnetization, one of the easiest ways to drop the magnet. So whatever you made the magnet, you just drop it. So if it comes under a force, that means you hit something, so you can drop it or you can take a hammer and nail. So what happens, it will lose its magnetism. Well, not the permanent magnet. The permanent magnet, very hard. I'm talking about the temporary magnet which you just made. So all of these magnetism that you make magnets, they are actually temporary. After a long while, do you know that if you leave the magnet around on your table and you didn't do anything, you will lose the magnetism and you may need to make it a magnet again. That's the difference between temporary magnet and permanent magnet. Okay, so this is one important point. So the second important point is how to make it demagnetize. First, you can leave it out for a long time and not use it. It will also demagnetize because it will go back to its old memory of how it was before it was magnetized. You can, if you immediately want to demagnetize it, you can drop it. You can hit with a force. You can heat it. That means put it in near a flame or some place that's very hot in the hot sun. Heat will also demagnetize it. And the third way is to use electrical method again. Electrical method, because you use the electrical method to actually make it, usually electrical method is slightly stronger magnet also compared to the stroking method. Yeah, okay, very good. Some of you asked me the question. Sure. Which one will make a stronger magnet? Is it a stroking method or electrical method? Most of the time it's the electrical method. Okay. Stroking method depends. If you go and stroke like 100 over times, maybe yes, it could be equal to the electrical method, but you have to stroke many times. But electrical method is fast because we make use of the power of the battery to send electricity through the wires, which is coiled. And so it will usually make a stronger magnet. And also it's very easy because we just put more batteries and more coils. So demagnetization, we can use electrical method as well. But how? Is it the same way as the magnetization? No, it's opposite. What we do is we send. Now this current that we send through is called alternating current, which is not in the syllabus. You're not required to know at this level. We will only be doing this at a higher level in secondary school. But I like to let you all have some idea of this. So in this side, what we call, let me pick up the pen that is in white. We call the current is a direct current. It will move in one direction. Whereas to demagnetize, we change the current type to an alternating current. And what an alternating current does is, remember I talked to you about the composition. One line you write right to left, another line you write left to right, then another line right. So imagine your teacher has to read this way, then this way, then this way, like a zigzag until her neck becomes like a snake. Okay, so nobody writes a compo like that. But if you want to play a fool, you can. And then your teacher marks, and then says, what is this compo? It doesn't make sense at all. They say, sure, you never read properly. You're supposed to read left to right. The next line is supposed to read right to left. So actually it went like this, your composition, okay? Nobody, I don't see any book that can be written like that to fool people, unless you just want to play a fool with them. Okay, so you can try it with your parents though. Like you write a compo and then you say, Daddy, can you check this compo for me? And then, of course, given that you have a lot of time and you want to play a fool on a weekend, okay? So alternating current is something like that. The current goes in, out, in different direction. One direction positive, then one direction negative, positive, negative. So that concept will be taught to you much, much later. But I just thought it's important that you have an idea of it. Okay, so that is not important for your exam purposes, but whenever you come to any science class, we just share a bit more. Okay, all good? Hope you had your lunch, you are very full, and this brain is also full of magnetic information. Okay, I will hopefully like to see you next week, but maybe not. Okay, because we are trying to make our website where you all have been going to do the questions, where you can go and revise anything you want at your own pace. Okay, so most likely we may not have a class and may discontinue, or we may start again closer to the exams. We're not sure. Okay, just keep a lookout for it. And in order to look out for it, you need to keep in touch with me with the website. As long as you're on the website a lot, you go to the website, you will know there's a chat function. You just type, hey, is there an online class next week? We tell you yes or no. Is there an online class coming during the exams? We tell you yes or no. What to do? You need any help? You have my WhatsApp number. You can check for my WhatsApp number with the website as well. But we are trying to focus you to fly into the website and pick the topics that you want to revise. Remember, you are supposed to revise the lessons that are being done in your school. So it's a mess if you are not doing magnetism, but I'm teaching you magnetism. But in the website, it's not like that. Wherever you are being taught, if it's animals, it's life cycles, you got life cycles, go straight to that. If it's electricity, go straight to that. If it's light, it goes straight to that. And then you do all the questions there. And you still see me week in, week out, because my videos are all out there. Yes or no? Those of you who have seen my videos, you know I am teaching day and night. Okay, 24 hours a day. Anytime you wake up in the morning, 6 a.m., you can click on me. If you wake up, if you're going to sleep at midnight or 2 a.m., you wake up, you can still click on me. I'll still be teaching there. Right? Okay.